Hello everyone, myself Hans. Today we are going to solve the given problem based on multiple integrals and volume find using the cylindrical coordinates. Question is given, find the volume of the region bounded above by the paraboloid z is equal to 9 minus of x square minus y square below by the xy plane and lying outside the cylinder x square plus y square is equal to 1. Let's solve the problem. Given equation of paraboloid is this is given by z is equal to 9 minus of x square minus of y square, and also the cylinder equation of cylinder is x square plus of y square is equal to 1 and bounded below the xy plane. Xy plane means intersect at z axis. We have to put z is equal to 0 in the equation of paraboloids. We get here 0 is equal to 9 minus of x square minus of y square, and from here minus of x square minus y square is taken to left hand side. We get here x square plus of y square is equal to 9, and from here we get the integral limit of r. Comparing the equation of circle, we can equation of circle, this is r is equal to 3 from here, and we can also find the integral limit of x from equation of cylinder. This is r is equal to 1, x square plus y is equal to r square, and further from here we can put the taking cylindrical coordinates, x is equal to r cos theta and y is equal to r sin theta, and we note z is equal to z, and from here we get x square plus y square is equal to r square. So we have to put here in place of given paraboloid. This is z is equal to 9 minus of, taking minus common, x square plus of y square. We get here z is equal to 9 minus of r square. We get the value of z, integral limit is z, and volume is given by triple integral. This is volume of given by triple integral. This is dz r dr into d theta, and from here we can put the limit of z here. This is 0 to 9 minus of r square, and the limit of r we have to calculate it. Lower limit is 1, upper limit is 3, and the limit of theta lies between 0 less than is equal to theta less than is equal to 2 pi. So the limit is 0 to 2 pi. First we have to integrating dz with respect to z. We get here 0 to 2 pi. This is the integral limit of theta, and the integral limit of r is 1 to 3. On integration of dz we get here z, and putting the limit here 0 to 9 minus of r square, and here is r dr and d theta. Putting here the upper limit, we get here this is integral limit is 0 to 2 pi, and the second limit is given 1 to 3, and putting in place of z 9 minus of r square, we get here 9 minus of r square, and this is r dr into d theta. Further we have to multiply with r. This is volume, integral limit is 0 to 2 pi, and the integral limit is also, second limit is 1 to 3, and we have to multiply with r. We get 9r minus of r cube into dr into d theta. Integrating with respect to r, we get here integral limit is 0 to 2 pi, and here we have to integrating 9r dr. This is 9 is taking constants, r dr on integration we get r square by 2, and minus of r cube dr on integration we get here r by 4 upon 4, and we have to applying the limit of r is 1 to 3, and putting the limit here, integral limit is 0 to 2 pi, and we have to first apply the upper limit here. In place of r we have to put in 3, 3 3s are 9, 9 9 are 81, this is 81 upon 2, and in place of r we have to put in 3, 3 to the power of 4, 3 3s are 9, 9 3s are 27, 23, once again 3 to the power 4 is given by 3 into 3 into 3 into 3, 3 3s are 9, 3 is 9, this is 81 minus of 81 by 4, and this is d theta. We have to missing out here d theta, and further solving this bracket we get here volume is equal to integral limit is 0 to 2 pi, and taking LCM here, this is 4, and 81 2s are 162 minus of 81, and this is d theta. We get here integral limit is 0 to 2 pi, 162 minus of 81, we get here 81 by 4 d theta. Taking 81 by 4 into outside, 81 upon 4, integral limit is 0 to 2 pi and d theta. On integration of d theta we get here theta, so we have to write here 81 by 4 and applying the limit here 2 pi here, so we have to writing here 81 by 4 into 2 pi, and this is 2 2s are 4, 2 2s are 4, and this is 81 pi by 2. Once again we have to checking 9r, this is 0 to 2 pi, 3 3s are 9, 9 9s are 81, 81 by 2, 81 by 2 minus of r to the power 4 by 4, taking LCM here 4, 162 minus of 81, this is 81 by 4, and on integration of, once again when solving for r, here we have to put in here once again some mistake here. When applying limit here, this is the upper limit. Upper limit we have to put in 3. We get here 81 by 2 minus of 81 by 4. And further we can put the lower limit here. Lower limit is 1. So we have to put in here, this is 9 by 2. 9 by 2 and minus of 1 by 4 and whole d theta. We have to solving 82 by 2 minus of 81 by 4 we get here. We get here once again. This is 81 by 4. 81 by 4 and minus of, we have to solving also this part, taking LCM is 4. LCM is 4, then 18 minus of 1. 18 minus of 1 upon 4, and this is whole d theta. And further we have to solving, we get here once again, we have to solving, we get here, this is 81 by 4 and 18 minus of 1, this is 17 minus of 17 by 4, and this is d theta. On solving, taking LCM is 4, 81 minus of 17, once again 81 minus of 17, we get here 4, and this is 7 minus 1 is 6. 64 upon 4, and integral is d theta 0 to 2 pi. Taking the constant 64 by 4 outside, and we have to cancel out 32 to the 64 and 2 to the 4, and again we have to multiplying here, dividing 2 and 2 to 16 to the 32, and we get here this is 16 integral of 0 to 2 pi d theta. On integration of theta is d theta is theta, so we have to get here 16 into applying the limit here 0 to 2 pi and putting the upper limit, we get the required volume 16 into 2 pi, we get 32 pi. This is the required solution of the given problem.